So our Battlefrog Rube Goldberg project is the PDM, the physics demonstration model. Tommy.
I'm Josh.
I'm Jacob, and this is our project.
Yep. So this is just a general overview of what we'll be covering in the presentation. We have the introduction, project planning, customer profile, use case, identification of customer needs, target specs, project management, economics, and conclusion. So just for an introduction, the focus is on the initial planning and research that has gone into designing the PDM. We saw an opportunity for a fun and yet visually stimulating project that could sort of differ from the traditional classroom setting of lecture and note-taking, which obviously gets very old, especially for high schoolers with short attention spans. In this case, we decided to focus on aiding learning of 11th grade physics, since that's pretty much consistently a hard topic for the students to learn. In particular, the conservation of energy, conservation of momentum, and angular motion. And our main goal was to have a high quality yet cost-effective product and to integrate Arduino programming, because computer science is one of the largest growing fields in the US right now, and it would give our product sort of an edge when buyers look at it. So we had three proposals that we had to choose from. Two of them were almost identical, so we combined them, which is why we only have two things in this S-curve. The main thing was just to have a hands-on physics learning project, as well as a small introduction to programming. And based on the S-curve, you can see that the Ferris wheel matures faster. However, the lead screw has a overall better performance in the long run. And our competitive strategies were based on customer focus as well as cost leadership. This is basically just our mission statement. It goes over what we wanted to do in this presentation, or for this product. So the product description is a high school education module that uses contraptions and an Arduino board to promote learning of physics, concepts, and coding. The key benefits would be that we would have a hands-on visual learning project for the students to participate in, and as well as aid in the learning of, as well as aid in teaching for teachers. The primary market was the parents of struggling students, as well as teachers who want to go above and beyond for their physics class. The secondary market would be an Arduino sort of module that can be bought online for at-home use. And then, so the customer profile, we had to generalize the target market into the typical customer that we would have. This typical customer would be passionate about teaching and helping students. It wouldn't be just your normal teacher who just presents day in, day out, just boring students to death. It would be a science-loving teacher who has many extracurriculars involved with the school to show their sort of dedication to the program and what's going on. And you can see here, this is our customer profile. We have the basic stats of what the teacher would be in terms of age and things like that, the attributes, as well as the activities that he or she participates in. Basically what they own, what they do not own, the buying habits that they have, as well as the philosophy of life that they live by. And I'm going to turn it over to Jacob.
So our next step was to create a use case to determine the typical functions of the product within the customer setting. So the teacher would pull out the product during class, tell them about the experiment that they were going to do, they being the students, and break them into different groups, so four people per team, and pass out the model. Then they would set it up, do the experiment, and deassemble it and put it back in boxes to give to the teacher again. And so then that was our first model, first way of function. And so we focused on making sure that we had a quick assembly, easy to store, quick deassembly, and setup time, making sure we had a good customization of the product itself, so making sure we have enough lessons to use it for. And so this is our use case, going through the first flow, second flow, and third flow, and then we listed some post conditions on how the students should react and fare after the experiment. Then we have business rules that we're going to follow throughout this project. Then we have our identification of customer needs, which is where we interviewed customers to determine what needs they wanted and what was important to them. And so from there we came up with making sure that the Arduino was easy to use, that we covered the topics we were supposed to cover, that it should look good and that the product should function reliably. So consistently being able to finish the experiment on time and with the correct response. So from that, we pulled those main 5 needs that we talked about recently and told the customers, hey, this is what we're looking at. Can you rate these 5 on importance? And so they did that, and another thing stood out with the aesthetics. They rated the aesthetics as a 4 instead of a lower number, which we were thinking of before. So that stood out to us as unique with the customer needs instead of what we were thinking of beforehand. And so from that, we took those needs and created specifications, which were functionality, aesthetics, Arduino difficulty, the textbook topics we covered, and the setup time. And we use those to determine how much our needs are met. And from this matrix that we have here, you can see that each of the specifications has a direct correlation to the needs. But something special is the Arduino difficulty and textbook topics covered are slightly more important because they have more needs that go into that specification. So then we went into the technical difficulties of making those needs and measuring those needs, and we ranked the number of topics as number technical priority because that is our entire function of the experiment of the product to make sure that they get the topics. And so it ended up with the topics and scale of measuring that was on top. And so next we're going to have Yash talk about project management and the finances.
Right, so to organize our project, we decided to use the Gantt chart, and the idea was that with that we'd be able to see the duration for each task, and we'd also be able to reel the schedule in if we were behind, and if we were ahead, we'd know exactly how far ahead we were. So here you can see our Gantt chart, and most of this has been addressed already by Tommy and Jacob. The important thing here is that concept testing and product architecture is what's supposed to be going on right now, but obviously because of midterms that we've had this week, we're slightly behind on that, which is fine because we left a lot of wiggle room here for prototyping. You'll see here that the only couple of tasks that we have on there are the design for manufacture, the economic analysis, and industrial design. And that's because the economic analysis we see as really an independent project once the target specifications are met, so we could have addressed that anytime, which we have done, as you'll see in the next slide. We've set aside 2 weeks for prototyping, and we hope that in case we run behind, we can reel the schedule in over here. So with the economic analysis, we decided to go with the scenario 1 approach of pricing objects because we just don't have enough experience to know if we can sell a certain number. We used the bottom-up approach and came up with a cost price per unit of $40, and we decided to price our product at $60. We also used a fixed overhead cost of $10,000, and as you will see, we break even if we sell 500 products, and our aim is to sell 1,000 products. Now, assuming that there's 6 groups per class, 3 sections per school, and it's sold in 2 grades, we'll break even if we sell to 14 schools. And so the idea is to double that and sell to 28 schools or a little bit less schools and more retail stores, and we should be comfortably able to hit our profit margin of $10,000. So moving on here, the big aim is obviously to stick to our deadlines, which is going to be hard because we all have midterms and we reach the final leg of the semester where everything just becomes a mess. The idea is to get to prototyping as soon as possible and sort of work ahead, work quickly, and maybe have slightly fewer iterations, and we'll see where we go from there.
Alright, so what we're gonna be doing today is just a lot of hand motions. That's good.